This lesson is on the fundamental theorem of algebra, which allows us to write any polynomial function in factored form, and we'll focus on given roots of a polynomial equation, we'll be able to write one of least degree. So if we have a polynomial function of degree n of 1 or greater, then we have at least 1, 0. If we have 2 or more, then they may be complex numbers. And it has exactly n zeros. So if we have a degree of 6, then we have 6 zeros. And that includes multiplicity. Now, the irrational and complex conjugate root theorems stem from the quadratic formula that irrational and complex numbers always come in pairs, and we've worked with those before when rationalizing denominators. So write the simplest polynomial function with the given zeros. So here, this is telling me that I have x equals 0, x equals 2 square root of 3, and hold on, that is an irrational number. So from the quadratic formula, that must have come with a negative as well. So I also have to infer that x is equal to negative 2 square root of 3, even though it's not provided in the example. And then x is equal to negative 1 as well. So I'm actually dealing with a 1, 2, 3, or a degree of 4 polynomial in the end. So now if they're not already equal to 0, I have to now move the number to the other side, and we get the following. So x equaling 0 stays that way, and then x minus 2 square root of 3 equals 0, and then x plus 2 square root of 3 equals 0, and then x plus 1 equals 0. Notice that because of the sign change, these are now opposite in sign from one another, and now we put them all together multiplied equals 0. So it's going to be x times x minus 2 square root of 3, x plus 2 square root of 3, and x plus 1. They all multiply to 0 because of the zero product property. And this, of course, is the reverse of if you were solving. It's because we're already given the answers or what the x-intercepts are. So now we need to be very careful on how we distribute, because these make a irrational conjugate pair. I want to multiply those together because the outer and inner products will subtract out to 0. So I have x times x for x squared, and then this is going to be a positive 2 x square root of 3, and then I'm going to have a negative version of that, and then I'm going to then have the product with those two numbers themselves. So negative 2 times positive 2 is negative 4, and then square root of 3 times square root of 3 is just 3. And now these will subtract out to 0. And so I'm left with the following. And I have negative 4 times 3 for negative 12. And then from there, you could just work left to right, however you want to distribute. So I will save the multiplication by x until the end. Distribute. I fixed that one distribution to make that correct as a square, and now I'll distribute in the last factor. And instead of equal to 0, I'll write it as a function. So I'll set that equal to f of x. and that is the polynomial with least degree that gives these roots, remembering that if you have an irrational, you have to infer that the other one is one of the roots of the polynomial function. Now in the future, you don't have to do all of that work. Really what you want to do is go right to that step because, all right, the opposite of 0 is just 0, so that's just x. And then the opposite of that is just negative, so you put that in with the x in parentheses, and then you infer that this one is also part of the problem. So you put that in opposite. It wouldn't be a bad idea just kind of to write that along the side, of course. And then it goes in opposite. And then you do the -1, put that in as opposite. And then you multiply them all together. So then you could save these two initial steps. Now, let's work with imaginary roots. They also come in pairs. So write them down. When you see anything with an I or anything with a square root, 2 plus I should come in a pair with 2 minus I, and then 3I will come in a pair with -3I. So this is a polynomial of degree 4 with 4 complex roots. So again, I'll go step by step, but then I'll point out where you can begin, and I'll mention all the shortcuts because otherwise this becomes tedious as well. So I set them all equal to 0. Rather, set them all equal to x, and now set them equal to 0. So I need to change the sign. So be very careful when you do this. And this is, of course, a step that you could skip. And now, with them all equal to 0, you can multiply them together to equal 0. So this would really be your first step now. So you would write you would have that. And now when you distribute, you want to, again, like last time, work with the complex conjugate pairs together because they will simplify very easily that way. If, on the other hand, you, let's say, multiply this pair of factors together first, the work is going to be very tedious, very difficult. So I'll take the first conjugate pair, and I'll distribute. So I get x times x for x squared. And then x times -2 is -2x. And there are shortcuts here that I'll show. And then x plus I. So x times I. Distribute the -2. And then distribute the -I. Notice that you put the I before the x like a coefficient. And I see a I squared coming, so I just want to change the sign. So -I times a positive I is equal to a -I squared, but I squared is -1. So that's really just a +1 here at the end. And then I'll do the same here. I'll multiply these two conjugate pairs together. And I'm not showing any shortcuts yet. So distribute. Okay, I see an I squared coming, so it's a -3 times 3, so that's -9, but then with an I squared makes that +9. Now we combine like terms. So because we had conjugate pairs, then this ix subtracts out with this -ix, and then this -2i subtracts out with this +2i. So I think there's going to be a shortcut coming out of that where you don't have to do the products that have an I to the first power, because when you multiply conjugate pairs together, the irrational or the imaginary parts subtract out. So combining like terms that remain, negative 2x and negative 2x, and then a 4 and a 1. And same deal here, those will subtract out. And this is much easier. It cleans up very nicely, and I'll show you a shortcut in a little bit, how we're going to skip all this and go pretty much right to here, then how to skip a lot of that and go mostly right to there. So I continue distributing to finish out the problem. It's a lot of work. And combine any like terms if possible, and then write in descending order. So this is the polynomial function f of x is equal to x to the fourth minus 4x cubed, and then I have a 5x squared and a 9x squared for 14x squared. And that is a polynomial of degree 4, which had those 4 complex roots. So now let's talk shortcuts. So I'm going to wipe this page and then redo this problem in a more efficient manner. I still want to write out the implied roots that come from the conjugate pairs, and then I always know it's x opposite because I need to change the sign. So my first step I really want is something like this. Don't get confused by the brackets. X opposite, x opposite, and then simply x opposite. So that's that one, and then x opposite. All right, so that skipped the first 2 steps, noting that I'm subtracting to the other side, because remember before it's like x equals 2 plus I, and then you subtract that over, and when you do that, that's like distributing this negative. So what I want to do from here is now distribute the negative, okay, so I'd even like to get right to here at some point if I get really comfortable with this, but at least be able to get to that step, x opposite, and then you distribute through the negative and you get here. And now I'm going to start breaking this down as a conjugate pair multiplied together. Remember that the inner and outer product subtract out to 0, so I'm not going to do them. I'm just going to do the first product, that's x squared, and then I'm going to do the last product, a negative 3 and a positive 3 with an I squared makes that a positive 9. And now, when I multiply these, remember the conjugate pair piece is with the I, because the I is the only thing that has the opposite signs. So anything with an I to the first power, I'm not going to write when I multiply it out. So I go, okay, x times x, that's x squared, that's fine. X times negative 2x, that's fine, doesn't have an I. But then x times I, skipping it. Okay, moving on to the next product. So I basically just did this, by the way. And then the last one you skip, because it will subtract out in the end. I already showed that. And next, I take the negative 2 and distribute it. And I don't write the negative 2i, that will subtract out. And then, okay, I don't want to write negative I times x. I don't want to write negative I times negative 2, because anything with I to the first power will subtract out. But this one I have to do, because that's negative I squared, or plus 1. And then you clean it up, and that's going to bring you to the same thing that I had before. in a much quicker fashion. It's less error prone, and you'll get the feel for what subtracts out and what products you get to skip. So this is going to bring together, using the calculator to find any of the rational x-intercepts, and then with synthetic division, we will distill out those parts of the polynomial to break it down into something that we could then finish with quadratic formula, factoring, completing the square. So on the calculator, after you put this in, you'll find the following zeros. You'll have -1 and 4 as x-intercepts. So -1, 1's really easy to multiply with, so I'll choose that first in the synthetic division. Order doesn't matter. I could start with a 4. You'll get the same thing in the end. And then for synthetic division, I go down, starting with the highest power of 4. Its coefficient there is 1. Leave a little space. Bring down the first term. Multiply, add down. Be very careful when you, like for example, don't multiply these and accidentally put a positive 3 here. That's where a common mistake will happen. And if you don't get a 0 remainder, then you made an arithmetic mistake, because we knew it was supposed to be a 0 or something that factors evenly into the problem. And now I pick up the 4 with the depressed polynomial, making my synthetic division 1 degree less. Bring down the first term. And again, confirming that what we found on the calculator was accurate. Now we factored out synthetically divided out 2 versions of x, so now we are at x squared plus 9, and that's great. I could use the quadratic formula, but it's a lot simpler just to use the square root property of equality. Taking the positive and negative square root of both sides and of a negative gives us positive or negative 3i that we then need to join with the roots that we found from the calculator. And we have 4 roots, 2 complex, 2 real, and that matches the degree of 4. And that's how you find all roots using the calculator, synthetic division, and then some algebraic techniques.